The migration of volatile organic and inorganic substances from subsoil to the atmosphere is an effect of contamination of soil or groundwater. Flux chamber is a device used to measure directly vapor flow rate, excluding external or background concentration of the ambient air, and mitigate and weather conditions at the outskirts. Now we'll speak about accumulation static flux chamber for screening analysis and after dynamic flux chambers. Once the sampling area has been identified, to find the exact position where to place the dynamic flux chamber, a screening analysis is performed to identify the point where the emission flow is higher or lower. This is possible by the use of a static accumulation chamber. The flux rate measurement is obtained by a train time function of a specific gas concentration, extrapolating the increase in rate proportional to the flow rate. A static accumulation chamber is a device that allows the measure of emission rate from some specific compounds, without introducing a gas carrier. The system works by accumulating the vapor inside the chamber and measuring the concentration trend of carbon dioxide, methane, total VOC, and H2S. A small pump takes the gas from inside the chamber and sends it to the sensor, that then reinserts into the chamber. Under these conditions, the concentration of the monitored parameters increase over time with a linear law. A software connected by Bluetooth to the device allows to evaluate the slope of the function that describes the increasing of concentration of the analyzed pollutants. The carbon dioxide and VOC concentration acquired by the instrument is displayed in real time on the device screen. In this way, it's possible to evaluate the progress of the measurement and immediately check the flow rate at the measurement point. The National Guideline SNPA 15/2019, Appendix B, provides for the use of the accumulation chamber in complex sites for the definition of sampling points. In paragraph 4, criteria for location of sampling points, it's specified that the choice of sampling points must take place by proceeding in progressive stages of investigation, providing preliminary identification of control points, applying the principle of geometric proximity to the probes or piezometries with more significant contamination and to the targets, possible screening of the concentration and flow rate of VOC and CO2 with accumulation flux chamber around 2-5 meters from this point of attention. The measurement with the accumulation chamber on the different points have been performed. Let's now examine the data recorded to map the emissive flows and identify the points with the highest or lowest emissive flow rate. On the basis of the values acquired on the flat file, the various processes are performed for the calculation of all the correlation functions that describe the increase in concentration over time of a specific parameter. Data processing is performed through the Flux software platform, capable of processing VOC and CO2 concentration data of the Thearen accumulation chambers. Data processing for each campaign, for each gas, considerant air or physical parameter, for the calculation of the emission flow rate, interpolation of the valid data and statistical regression of the values, quantification of single point of emissivity, statistically robust calculation of the emission value of each measured point, and the relative confidence limits for each measured parameter. Let's now see how a dynamic flux chamber works. This is the dynamic flux chamber patented by Thearen together with the Engineering University of Milan, built after a development project that lasted several years. In a dynamic flux chamber, a carrier gas, normally high purity nitrogen, is injected in a controlled flow inside the chamber by means of connecting lines with a particular spiral geometry. The gas, in contact with the soil, enriches itself by the volatile compounds in emission from the surface and goes out by the vent holes. VOC are collected and determined in the output stream by specific sampling and analysis methods. Before to start sampling, it's necessary to purge the system, replacing all the air present initially inside the chamber by the gas carrier. To achieve complete mixing of the gases inside the chamber, the Thearen chamber is characterized by a spiral-shaped gas distribution system. In this way, the chamber is always completely mixed. In fact, a minimal air intrusion from the outside can alter chamber's internal conditions. To avoid this problem, Thearen chamber uses a tubular-shaped windbreak, positioned above the upper base to protect the vent holes. Fine sand is placed around the chamber to seal the equipment to the ground and to prevent external air from entering the chamber itself. The sand must be periodically humidified, especially in hot season, to maintain its sealing effect. Sand must also be placed around the windbreak to protect the sampling holes and the vent hole. The system has been tested with laboratory tests and field tests to verify wind resistance. Air intrusion didn't occur even with winds at 10–15 meters per second. During sampling time, as well as the national guideline SNPA 15/2018 requires, all information useful to describe the sampling activity and the surrounding condition must be recorded. Thearen has developed the field app that works on mobile devices, smartphone or tablets, that allows you to record all the sampling information and add multimedia evidence for process validation. The coordinates of the sampling points are recorded, the information about the sampling surface and all the measurements carried out in the field are recorded into the app. All images of the sampling process are added directly to the digital report. Both during purging and during sampling, physical and chemical parameters must be measured to ensure proper monitoring management. The initial purge must be of a volume equal to about 4–5 times the internal volume. For the Thearen chamber, which has a volume of about 40 liters, and the carrier gas is normally pumped at 4 liters per minute, purge time is 45–50 minutes. During the purge, the measurement must be made every residence time, while during sampling at least once an hour. The sampling time is normally never less than 4 hours, normally 6 hours. The parameters that must be measured are oxygen inside the chamber, carbon dioxide inside the chamber, methane inside the chamber, VOC with peat inside the chamber. Then, delta P measurement is very important to verify that there's no intrusion of external air and the system is well controlled. It is also necessary to measure the temperature and humidity inside and outside the chamber. Normally, even in very critical condition, the opaque PTFE material, which the chamber is built, maintains the same temperature inside the system, avoiding harmful greenhouse effects. Remember to periodically check the nitrogen flow during sampling, since the flow value is one of the fundamental parameters for the calculation of the emission flow rate of chemical compounds monitored. The choice of the sampling support, and therefore the analysis technique, in addition to depending on the chemical physical nature of the pollutant, cannot ignore the extent of the present contamination of the site and the site-specific risk thresholds, in particular for VOC and hydrocarbon fractions. Generally, in unknown sites whose history doesn't give any certain information on the extent of contamination, it is useful to proceed before the monitoring campaigns or directly in the first campaign of Orevol to a screening campaign by sampling the soil gas on different substrates to have information necessary for planning subsequent campaigns. Canisters are the most suitable substrate for the sampling of light organic fraction and for individual VOC. However, sometimes it's sufficient to use activated carbon solvent tubes to reach the required concentration limits. Normally, the concentration involved compared to sampling with nasty probes tend to be much lower, because the emissive flow is mixed and diluted by the carrier gas, and because the flux chamber is placed at ground level, downstream of the phenomena of dispersion and biodegradation that occur during transport to atmosphere. Bye bye! Data verification and validation are an important step in the monitoring process because they ensure the quality of the data associated with monitoring with flux chambers. Thearen examines the quality data of the laboratory analysis by checking the correct execution of the QCs through automated system and knowledge of environmental chemistry. The final result is a validation report that not only summarizes the characteristics of the flux chamber and the patented technology of Thearen, but also reports the validation of all the fields data recorded through the app and the validation of the quality control of the analysis laboratory, putting a quality seal on the entire process.